December 21, 2012, The Real Doomsday. By Dan Eden for ViewZone. ViewZone asked me to write a story about the Mayan calendar. There is a common belief that the calendar holds a prophecy that the world will end in 2012. I knew very little about the whole topic when I began doing the research. I like to think I had an open mind. My investigation began with mainstream archaeology and expert interpretations of the calendar. But it soon took a turn that made my hair literally stand on end. I am now convinced that these prophecies are true. To understand what is likely to happen to Earth and its people, you will need to remain calm and try to follow the facts. It's not as simple as some people describe. It requires an understanding of some fairly complicated science, but I think I can explain this in a way that you will easily understand. The calendar, a description. First, the Mayan calendar is also sometimes called the Aztec calendar. This calendar is recorded as a carving on the Aztec sunstone, currently on exhibit in the National Museum of Anthropology, and historically located within Chapultepec Park, Mexico City. There's a lot we could say about this carved stone, but most of those details are irrelevant to the end times. Our modern calendar, called the Gregorian calendar, has days, weeks, months and years. In the Mayan calendar it's more complex. In fact, it's really 3 calendars at the same time. First, there's a religious calendar that takes 260 days to complete a full religious cycle. There are 20 weeks, made up of 13 days. Each week has a special name, a graphic logo, and unique meaning associated with it. This reminds me of the Chinese years, which cycle through the year of the rat and the year of the monkey, etc., each with its special image and meaning. Next, there is the solar calendar. This has 365 days, like our modern calendar. It's divided into 18 months of 20 days each. At the end of the cycle there's 5 special days considered to be unlucky because they don't belong to any month. Each of the months has a special name, graphic logo and some special significance, similar to the icons for the weeks in the religious calendar. So, it is possible, for any specific date, to calculate the religious week and the solar month and to predict the influences that might be guiding fate. But that's not really what's involved with the prophecy of 2012. To understand that, we must look at the third calendar, called the long count. While the first 2 cycles could be thought of as cogs, or gears, revolving through time, the long count is a linear number of days, starting from the first day, 1, and counting through each day to the present. Any day in history can be recorded using the long count and, with some simple mathematics, the corresponding religious week and solar month can also be found. In writing this article, I thought about creating a JavaScript program that would do this calculation. My friend, Gene Matlock, then told me that when he was in Mexico, he found a place that sold wooden, mechanical calculators with gears that did just that. He said that Mexicans sometimes use these mechanical calendars to foretell the future, or to find auspicious times for special events like marriage or births. Anyway, although it might be nice to know the religious and solar significance, it's the long count that foretells doomsday. Cogs, or gears, can be used to compute the religious and solar cycles for any date. The days of the long count are numbered with an unusual system. Instead of writing numbers as we do, from right to left with each place being a multiple of 10, for example, 10,000, 1,000, 100, 10, 1, the Mayans had only 5 places. The first place recorded a number from 0 to 20. To the left, the second place could have a range from 0 to 17, the third from 0 to 19, the fourth from 0 to 19, and the last from 0 to 12. The numbers were written from right to left, like our system, separated by a dot. Instead of multiples of 10, the first place had a multiple of 1, like our system, the second place a multiple of 20, the third a multiple of 360, the fourth a multiple of 7,200, and the fifth a multiple of 134,000. So, a long count number, for example, could be written as 4.12.5.9.0 and would be calculated as follows: 4 times 134,000 plus 12 times 7,200 plus 5 times 360 plus 9 times 20 plus 0 times 1, or a long count of 135,980. It's not too difficult to realize that the maximum number which can be recorded this way would be December 19, 2019. 17.20, although some researchers like to write it as 13.0.0.0.0. This amounts to a long count number of 1,872,000 days, or 5,125.36 years of our modern calculations. Obviously, the calendar is very old. Over the years, archaeologists have found carved monuments that recorded the long count for known dates in Mayan history. Once a date was fixed in time, it was easy to determine day 1 as August 11, 3114 BC, and it was also easy to calculate the date at which the calendar would end, December 21, 2012. Trust me, just because the calendar ends, doesn't prove that time, or the world, or life, will end. We need to look carefully at December 21, 2012 and try to understand why the Mayans never calculated a date beyond this point in time. To do this, we must move from archaeology to the science of astronomy and astrophysics. It's all about the sun. It's ironic, or maybe not, that the Mayan calendar is often called the sunstone. While the calendar does have solar days, acknowledging the 365 days it takes for Earth to rotate around the sun, it is also true that the sun plays a key role in the final day of the long count. To understand what will happen to the sun on December 21, 2012, we need to review some scientific terms like ecliptic, barycenter, and sunspots. These are important in the discussion that follows. We'll start with the most difficult one first. What is the barycenter? You've no doubt heard that Earth revolves around the sun. Well, actually, That's not quite true. Have you heard the term center of gravity? It's a technical sounding term for something pretty simple. It's the exact center of all the material, that is, mass, that makes up the object. For example, if you have a straight stick, like a ruler or yardstick, there's a place at the middle where you can balance it on your finger. That's its center of gravity. But the center of gravity may or may not be the point that is exactly in the middle, distance-wise, of the object. Some parts of the object may be heavier, or denser, than others. If you have something like a sledgehammer that is heavier on one end than the other, the center of gravity would be much closer to the heavy end than the lighter end. We can take advantage of this bit of knowledge and look for large planets and other solar systems by learning to detect this type of tiny wobble in the star's position. To get an idea of where the center of gravity is, rest the ends of any object like the ruler or a pencil on one finger from each hand. Slowly move your fingers together, without dropping the object. Your fingers will meet underneath the object's center of gravity. You can balance the object on one finger at that special place. The actual center of gravity could be close to the surface or deep inside, depending on whether the object is flat, like a ruler or a dinner plate, or three-dimensional, like a box or a ball. And if you let the object spin, like when you throw it, it will try to spin about that point. In the case of the Earth and the Sun, both bodies actually revolve, or spin, around the very center of the mass, similar to the center of gravity, between them. This point is called the barycenter. Earth and the Sun are connected by the gravity pulling them together. It's just like the light end and heavy end of the sledgehammer. Compared to the size of the Sun, Earth is about like a flea on a cat. So, the center of mass between the Earth and the Sun is almost, but not quite, the very center of the Sun. In the case of a planet the size of Jupiter, which is 318 times as massive as Earth, the barycenter of Jupiter and the Sun is a bit further from the Sun's center. So, as Jupiter revolves around the Sun itself is actually revolving around this slightly off-center point, located just outside its center. Thus, a planet the size of Jupiter will make the Sun, or any star, appear to wobble a tiny bit. We can take advantage of this bit of knowledge and look for large planets and other solar systems by learning to detect this type of tiny wobble in the star's position. For now, let's forget all the small planets and focus on Jupiter. It makes one complete trip around the Sun every 11.861773 years. There's a new theory put forth by Dr. Rollin Gillespie, which shows that Jupiter, and to a smaller degree the other less massive planets, may trigger the 11-year cycle of sunspots and solar flares. Here is how it works. The barycenter is not a single point in the Sun. Because the Sun is a rotating, gaseous sphere, the barycenter forms a vertical, cylindrical sleeve that is partially inside and outside the main solar body. All of the planets have such a sleeve, one inside the other, depending on their relative mass and the location of their barycenters. The particular sleeve representing the mass of Jupiter intersects the solar surface at 35.9 degrees north and south. This is precisely where sunspot and flare activity begin and end, during each 11-year cycle. The new cycle has already begun with the recent observation of a solar spot with reverse polarity. But some surprising activity on March 27, 2008, shows some huge eruptions with M-class radiation at about the equatorial region of the Sun. These surprising eruptions suggest a barycenter of disturbance from an object even more massive than Jupiter, placing the sleeve outside the Sun. Could this be the beginning of the galaxy's effects? Scientists have noted that when Jupiter and Saturn are aligned on the same side of the Sun, the solar activity is at its minimum. When they are on opposite sides of the Sun, the solar activity is at its maximum. The positions on December 21, 2012 are ideal for extreme solar activity. These cylinders are usually quite orderly because the planets adhere to a narrow plane, called the ecliptic, which resembles a thin plate extending from the equator of the Sun. The planets hang out here because, in simple terms, this is the zone where the gravitation of the system is the strongest. The planets orbit the Sun in a narrow plane called the ecliptic. But nature is never perfect. The Sun rotates at a slight angle, 7.25 degrees, much as our Earth does. As it wobbles, it tilts the sleeves, causing them to clash with each other and eventually disrupt the surface. Having the barycenters of the two most massive planets, Jupiter and Saturn, in maximum misalignment is especially disruptive. This disturbance, to put it simply, works its way to the surface and erupts in sunspots and solar flares or CMEs, coronal mass ejections. The last solar cycle was at its maximum in 2001. Each active solar cycle has a period when the flares are strongest, usually happening near the solar equator, called the solar maximum. This is significant because the next solar maximum event will coincide with December 21, 2012. But wait, there's much more. Solar flares are pieces of the Sun which leap into space, discharging radiation and strong electrical currents that travel outward into space. They often fall back to the surface of the Sun. Sometimes, a very strong flare, called a coronal mass ejection, CME, actually leaves the Sun, and this deadly mass shoots out from the Sun towards the planets like a bullet. Usually these CMEs don't hit anything, but occasionally they hit a planet like Earth. Some believe a powerful CME once hit Mars. Most solar flares are small. But even a small flare can be dangerous. In 1989 a flare hit the North American continent and fried electric lines, zapped power grids in the US and Canada, and created large power blackouts. Flares can also affect our moods and physical health. In theory, a large flare impacting the Earth could zap the ionosphere. There goes all the satellites, cell phones, GPS, and irradiate the surface, killing every living organism that it touched. Solar flares and sunspots have an average cycle of 11.120412 years, estimated from one solar maximum to the next. Right now, in 2007, we are in a relatively quiet part of the cycle. The small discrepancy between this figure and the 11.861773-year period of Jupiter is close enough to be significant, but suggests that something else is also influencing solar disturbances. Sure, it could be attributed to the various positions of the other less massive planets, but it could also be something even more significant. The Milky Way. The galactic alignment of December 21, 2012, the perfect storm. Our solar system is part of a huge disk-shaped collection of stars and planets called the Milky Way. We're located somewhere on the edge of the disk, slightly on top of the narrow disk. But very soon we'll be moving to the bottom of the disk. This change, from top to bottom, begins on December 21, 2012. Yes, that's right. On the same day when our sun is at its solar maximum, something will happen that's never happened before. The ecliptic of our solar system will intersect with the galactic plane, called the galactic equator of the Milky Way. If you imagine our solar system as a bunch of peas on a plate, with a huge meatball in the center, imagine the Milky Way as a city-size pizza with the Guinness World Book Record meatball in its center. Prior to December 2012 we have been drifting on the top of the pizza, never really able to see the bottom. The plate and pizza are not parallel. They are moving at different angles. We've been drifting down, 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 and on December 21, 2012, we will be exactly level with the crust, forming an X at the galactic equator, where galactic gravity is the strongest. After 2012, if we are still here, we will be passing through the bottom zone, viewing the Milky Way pizza from the south. Yes, there's even more. By some amazing coincidence, not only will we be intersecting with the galactic equator, but we will be doing this precisely aligned with the center of the galaxy where there is maximum mass. More mass means more gravity. More gravity means more influence from those barycenters in our Sun. That means exponential increases in solar disruption, all coinciding on the same day. Whoa! The Hercules cluster of galaxies. This group of galaxies is held together by the gravitational attraction or pull of each individual galaxy on the others in the group. This demonstrates the enormous gravity contained in a galaxy, such as our own Milky Way. And apology and acknowledgement. Okay, this has been a lightweight description of what's going to happen. It has been simplified to the point where some scholars and scientists could argue about my presentation. But the main facts are true. The date, December 21, 2012, is a special day. It represents the maximum possible influences for solar flares that the universe can provide. Undoubtedly the Mayans, or the civilization that influenced them, somehow knew about these things. Over the last decade, I have written a variety of stories about such things as underground cities and government actions that could only make sense if there were no future. I cannot help but think that maybe they, like the Mayans, know about these things. I'd specifically like to suggest that readers take another look at the underground complex at Humantau that the Russians are building. Could this be a haven for surviving a solar blast? and the Doomsday seed bank that's being filled deep inside an Arctic island. And what about past events? Did the Hopi go underground to survive a similar event thousands of years earlier? Should we be going underground also? It's also important to stress that December 21, 2012 is only the solar maximum, but that the gravitational effects of the galaxy have already started to assert their influence on the Sun. The drift towards alignment with the galactic equator is relatively slow and, in truth, has already started. But the precise culmination of this, plus the alignment of Jupiter and Saturn, all make 12/21/12 an ominous date. I especially want to thank Dr. Roland Gillespie, a man with whom I corresponded for 10 years and who first developed the idea that planetary multi-body systems could be at play in the causation of solar flares. More of his work can be read on a special page on ViewZone. Comments. Physicists find evidence for highest energy photons ever detected from Milky Way's equator. From Science Daily, physicists at nearly a dozen research institutions, including New York University, have discovered evidence for very high-energy gamma rays emitting from the Milky Way, marking the highest energies ever detected from the galactic equator. Their findings, published in the December 16 issue of the Physical Review of Letters, were obtained using the Milagro Gamma Ray Observatory, a new detector located near Los Alamos, New Mexico, that allows monitoring of the northern sky on a 24-hour, 7-day-per-week basis. Gamma rays are considered by scientists to be the best probe of cosmic rays outside the solar neighborhood. The research team, which includes nearly 40 physicists, reported that Milagro, positioned at an altitude of 8,600 feet in the Jemez Mountains, detected a signal along the galactic equator region and interpreted it as arising from gamma rays with a median energy of 3.5 trillion electron volts, or 3,500 times the mass energy of a proton. Previous satellite experiments have seen gamma-ray emissions along the galactic equator reaching up to energies of only 30 billion electron volts. These emissions are understood to be produced by interactions of cosmic ray particles with the abundant interstellar medium near the galactic equator. Previously, some researchers had speculated that additional mechanisms were needed to explain the large number of particles observed at high energies. However, the measurements by Milagro can be understood by assuming a cosmic ray energy spectrum near the galactic center similar to that in the solar system and the standard properties of particle interactions. The results presented in the Physical Review of Letters paper were gathered over a 3-year period, beginning in July 2000.